All right, today we are having our unit review. Our quiz is going to have 20 multiple choice questions. It will be on CodeHS as is the usual. So there you go. What we have talked about in this unit is we have essentially recovered all of Unit 2 in more depth with more specifics. So the first thing we talked about was access specifiers. We talked about how everything in a class needs to have an access specifier, either public or private. Anything that is marked as public can be accessed and modified from other classes. All classes should be marked as public, so you should never have a private class because Java will get mad at you if you do that. Usually you're going to want your constructors to be public because otherwise you will not be able to create instances of your class from other classes, which you usually are going to want to do when you're building classes. And you will mark most of your methods as public so that other classes have access to them. Anything that is marked as private can only be accessed from within the class where you declared it. Instance variables are almost always going to be marked as private, and depending on the situation, you might mark some of your methods as private as well. Since we have private instance variables, we as the programmers must choose whether we want those variables, those values, to be accessible, modifiable, both, or neither. And based on that decision, we are going to implement either accessor, mutator, both, or neither of those types of methods. We'll get into those later. When we are creating instances of our class, we need to call our constructors. And within the constructors that we write, we should initialize all of the instance variables for the object. Even if we are planning on giving one of them a default value, it is good practice to have all of them displayed, all of them initialized, because then it is clear to anyone reading your code what the intention was. So if the intention is to initialize a variable to 0, I would include that in your constructor so that it is clear that it is purposeful. If you do not have a constructor in your class, Java will provide you with a default constructor in which all of the instance variables are provided with a default value. So numbers are usually going to, or not usually, numbers are going to default to 0. Objects are going to default to having a null reference. I believe strings are just going to be empty. So anything that does not get initialized will just be essentially empty. It'll be given a value of 0. We are allowed to have objects as instance variables in our classes. When we are initializing these objects, it is important that we do not create aliases. So we want to, if we're given a parameter of an object type, we want to initialize our instance variable object with the same values as that parameter, but we want to make a new object so that we do not have aliases. Otherwise, we can run into some potentially weird errors that we don't want to encounter. All right. Anything that you would like me to clarify yet? Cool. All right. Documentation with comments. In order to make our code more readable by human beings, so by other programmers, or by ourselves in the future, we are able to add comments. These snippets are ignored by the compiler and therefore do not change how the code runs, but they are there to clarify any potentially confusing sections for programmers who are reading our code. There are 3 different types of comments that we can add in Java. We have single line comments that we start with a double forward slash. And those are for quick little notes about confusing lines of code. I personally recommend that you put them above the line that you're explaining because people read from top to bottom. We have multi-line comments, which start with a forward slash, then an asterisk, and they end with a matching asterisk forward slash. Those will ignore anything that you write in between those 2 sets of symbols. And those are used for describing longer sections of code, particularly methods or a long loop, if you want to explain what that loop is designed to do. And then we have our Javadocs comments, which are used to create formal documentation for a class. And while creating documentation is not a super fun exercise, it is necessary for doing software development. So it is an integral part of this profession. So our Javadocs comments start with a forward slash and a double asterisk, and they end just like a multi-line comment with an asterisk and a forward slash. And they follow a specific format. You're going to have a description of what the code is doing. We've got preconditions, postconditions, and block tags. So preconditions are going to describe the state that your program must be in before your code can run as expected. Often you're going to describe the parameters for your method, if you're describing a method, as well as any rules that those parameters must follow. So if these parameters need to be within a certain range of values, you would specify that in your preconditions. Your postconditions are going to describe the state of the program after the code that you're describing has been run. After this is going to describe the values being returned or any changes that are made to instance variables within this code. And last, we have our block tags, which are going to follow the format at the name of the tag, whatever variable you are describing, and then a description of said variable. 2 very common tags here are at return and at param, which are going to describe the value or values being returned from the method and the parameters being accepted by the method, respectively. Now, neither of these is required. If your method doesn't return anything, you're not going to include an at return. If your method does not have any parameters, you're not going to have an at param. So if you have neither of those things, you will have neither of those block tags. All right. Accessors and mutators. Like I said earlier, since our instance variables should always be private, we need to create public methods so that other classes are able to interface with those variables. Their accessor methods, also known as getter methods, are used to retrieve the value of an instance variable for another class. And they're often named get and then the name of the variable. And since we are returning a value, the return type of your method must match the type of the variable that you're returning. Just like any other method where we're returning a value, we need to match our types. Mutator or setter methods are used to assign a new value to an instance variable. They're used so that we can change our instance variables after we created the object, because we don't need to call a constructor again. We don't need a new object. We want to make a change within the object we've already created. So that's what mutator or setter methods are useful for. They are often named set and then their variable name. Their return type is usually void. Since all we are doing is reassigning a variable's value, we're not going to be returning anything. And these are especially useful because they let us add some error handling before we change our instance variables. We can make sure that our instance variables do not enter a state, do not get a value where our class could get into an error state. So we can have a sequence of if statements. We can have whatever we want to assign values to our instance variables. And keep in mind that if you have an instance variable that is an object, if you return it using an accessor, that will create an alias. Now, sometimes this is useful. Often this is useful. If you want to reference that exact object, clearly you're going to need an alias. But just keep that in mind. If you ever change the values within that object, once you've retrieved it, it's going to change the actual instance variable for the class as well, or for the object as well. So just keep that in mind. When we write methods, we are going to declare the formal parameters for those methods. And remember, within declaration, we need to provide a type and a name for that variable. And then when we call our methods, we are passing actual parameters to those methods. So we are providing a value for those formal parameters. So our values of our actual parameters are used to initialize the formal parameter while the method is running. When a formal parameter is an object, it will be an alias of the object that you pass as the actual parameter. So if I am getting a rectangle object as a parameter, any changes that happen to my rectangle object inside my method will affect the object outside of the method as well. So we should take care to only change objects in the methods where we are explicitly stating that we're going to do so that we can avoid confusion. All right. Any questions on this thus far? Cool. All right. So the static keyword, we learned a lot more about it this unit. The static keyword can be added to either variables or methods within a class. Anything that you mark as static is going to belong to the class as a whole instead of any specific object or instance. So you can reference them from the name of the class rather than from an instance of the class. And static variables are going to belong to all objects of the same class. If you change the value of that variable within one object, it's going to be changed within every single other object. And this is useful for keeping track of how many types of that, or how many instances of that object you've created, for one possible example. Now, static methods can be called with or without an instance of their class. Usually, you're going to use the format className.method. However, you are able to use an instance of that class if that class is able to be instantiated in the first place. The math class, for example, cannot be instantiated, so we're always going to say math.method. But in our superhero example, the superhero class could be instantiated. So a static method within the superhero class, we could either call it from an instance of that superhero class or from the superhero class itself. When we are within a static method, we cannot access non-static variables and methods, because from our class point of view as a whole, we're not going to have access to any information specific to any given instance. So we cannot access any instance variables because we might not have an instance when we are working on getting that information. This is not true the other direction. We are absolutely allowed to access and call static methods and variables from non-static methods. So we cannot access non-static things from inside of a static area, but we can access static things from a non-static area. All right, does Static all track. Okay. Scope and access. Scope is what defines where a variable exists and where it can be accessed. The scope of a variable is determined by where in your program you declared that variable. A variable will be in scope. It will exist from the point where you declare it until the end of the block in which it was declared. And a block is defined by a pair of curly brackets. So once it hits the closing curly bracket for the block, it is going to stop existing. It will be out of scope. If you have multiple variables in different scopes, however, if you have multiple variables with the same name, the variable with the more specific scope will be used, and any others with the same name will not be. There we go. Back. All right. So, like I was saying, if you have multiple variables within the same scope with the same name, most specific scope is going to be used. The others will be ignored and not changed whatsoever. This is called shadowing. And we can most often avoid shadowing using the this keyword. Now, keep in mind that parameters are local variables for their methods. So if you write a method, public void, let's say we're writing set width within the rectangle class. Public void set width with int width as my parameter. If I just say width equals width, this is not going to work as intended. This is not going to change my instance variable, because here, that parameter width, while it is on the right side of my equals here, it is also technically on the left side of my equals. So I am going to be assigning a variable the same value as it already held, essentially accomplishing nothing. So if we want to have our parameters for our methods have the same names as our instance variables, we can use the this keyword. This keyword refers to the object on which a method or constructor was called. So if I called rect1 dot set width 5, then inside of the set width method, this would refer to that rect1 object. If I went and called rect2 dot set width, within that method call, this would refer to rect2, etc. So this allows us to reference our object's instance variables specifically. So if I say, instead of just width equals width, if I say this dot width equals width, then we are explicitly pointing out we don't want that variable width. We want to use our instance variable width. We want to use a completely separate variable and assign it that value of the parameter. So even though these have the same name as our instance variable, we are no longer referencing that parameter variable when we are to belong to the current object. So we can also use this keyword, this object, in the same way that we could use any other object. We can pass it as a parameter, we can call its methods, and we can access its instance variables. Because it is an object of the type of the class in which we are working. Obviously, we can access all of its private instance variables. And the same is true of any object of the same type as the class we are currently working in. If I'm in the rectangle class, if I'm writing code in the rectangle class, any rectangle object that I get as a parameter for any of my methods, I can access its instance variables as though they were my own instance variables because we're within that same class. It's not bigger. Well, the D10 is still rejoining, so we are just gonna wait for that to happen. Just gonna continue our lesson, our review time, because we are almost done. So, like I was saying, it is important for us to remember as computing professionals, our work creating software can potentially have huge implications on the world. So the Association for Computing Machinery, or ACM, has a professional code of ethics. They have stated, they say that computing professionals should follow all of these guidelines you see on screen. They should contribute to society and human well-being, acknowledging that all people are stakeholders in computing. They should avoid harm, be honest and trustworthy, be fair and take action not to discriminate, respect the work that is required to produce new ideas, inventions, creative works, and computing artifacts, respect privacy, and lastly, they should honor confidentiality. So, with all that in mind, remember, what you do has an impact no matter what it is, whether you go into computer science as a career or if you choose something else, you are always going to have an impact. So make sure you have a positive one. And there we go. We'll see how the recording for this looks because boy howdy.